Good day and welcome back to my channel. In the next few videos we will be looking at the fundamental counting principle. The fundamental counting principle deals with permutations, which is basically the number of ways to accomplish different tasks. If there are m ways to perform a certain task and n ways to perform another task, both tasks can be performed in m multiplied by n ways. Now let's look at an example to illustrate this. The example reads, at a party there are 2 choices for starters, 3 choices for mains, and 3 choices for dessert. How many different meals can be made? Now, using the point we discussed in the previous slide, the number of meals is simply 2 multiplied by 3 multiplied by 3. As there are 2 choices for starters, 3 choices for mains, and 3 choices for dessert. So there's a total of 18 different meals that can be made by the guests. Now let's look at another example. The example reads, a safe requires a 4-digit code. How many codes can be chosen if, number 1, the safe allows repetition of digits, and number 2, the safe does not allow repetition of digits? Let's look at the first one. In the first one, the safe allows repetition of digits. And we know that we can choose digits from 0 right up to 9, which is a total of 10 digits. So if there's a 4-digit code, then in the first position, or the first digit for the code, there's a total number of 10 digits that can be used. For the second digit, there's also a total of 10 digits that can be used. 0 right up to 9. For the third space, there's also 10 digits, and likewise for the fourth space. So in each space in the code, there can be a total of 10 digits that can be used. So in order to get the total amount of combinations, it's simply 10 multiplied by 10 multiplied by 10. And that gives us 10,000 combinations. Now for the second one. The second one says the safe does not allow repetition of digits. In that case, for the first digit, there's a total amount of 10 digits that can be used. Now, whichever digit is selected for the first digit, that digit needs to be eliminated, as we cannot have repetition of digits. So now, in the second space, there can be only 9 digits that can be used. Likewise, in the third space, there can only be 8 digits that can be used. And the fourth space, we can only use 7 digits. So our answer is simply 10 multiplied by 9 multiplied by 8 multiplied by 7. And that will give us the amount of combinations that can be made if the safe does not allow repetition of digits. Now let's look at a notation that will help us with these type of problems. In factorial notation, the factorial of a natural number is the product of the positive integers less than or equals to that number. Let's look at 5 factorial as an example. 5 factorial is equals to 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. 7 factorial is 7 multiplied by 6 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. I think you get the point. It's important to note that 0 factorial has a strange but interesting property of being equals to 1. So 0 factorial is equals to 1. Now let's look at an example involving factorial notation. The example reads, a grade 12 learner has accounting, Zulu, science, and math textbooks. How many different ways can they be arranged on a bookshelf? Now, there's a total of 4 different textbooks, so there would be 4 spaces. In the first space, we can put any of the 4 textbooks. Once we put the first textbook down, there's only 3 textbooks remaining. So in the second space, we can only put a total of 3 textbooks. And likewise, in the third and in the fourth space. So our answer is simply 4 multiplied by 3 multiplied by 2 multiplied by 1, which is simply equals to 24. However, this can also be written in factorial notation as simply 4 factorial, because we know that 4 factorial is the same thing as 4 multiplied by 3 multiplied by 2 multiplied by 1, and that is also equals to 24. Let's look at a more complicated example. The example reads, there's 2 different history books, 3 different geography books, and 2 different science books. How many ways can they be arranged? Now, using factorial notation, which we've just learnt, we can simply write this as 7 factorial, because there's a total of 7 books, and 7 factorial is simply equals to 5040. Now let's look at the second part of the question. The second part of the question is, how many ways can they be arranged if books of the same subject must be placed together? Now we see that this example is slightly more complicated, and we will use grouping in order to solve this question. Now if you remember, there was 2 history textbooks, there was 3 geography textbooks, and there was 2 science textbooks. Now, in order to solve this problem, we will look at each subject individually. So, how many ways can the books of history be arranged? Since there's only 2 books, 2 history books, they can be arranged 2 factorial ways. Since there's 3 geography textbooks, they can be arranged 3 factorial ways. And since there's 2 science textbooks, the science textbooks can be arranged 2 factorial ways. Now that we've looked at each group individually, we have to look at the entire bookshelf. So history, geography, and science can be arranged how many different ways? The 3 subjects can be arranged 3 factorial ways. So a problem like this will be solved by first individually looking at each subject and then combining all of the subjects and looking at how many ways can each of the subjects be arranged. So 2 factorial multiplied by 3 factorial multiplied by 2 factorial multiplied by 3 factorial is simply 144 ways. So we can see there's a massive difference if we simply put the books in any way compared to if we put the books subject by subject. 5040 ways if we put the books in any order, and if we put the books subject by subject, there's only 144 ways that they can be arranged. I hope you enjoyed this video. If you enjoyed this video, please give it a thumbs up and subscribe to my channel. Stay tuned for part 2 of the fundamental counting principle.